Ika Viksikukun, new pack for ice bridges.
Hi, I'm Ryan Harris. I'm the mechanical engineer at the Lamont campus of Columbia University. I both design and build the equipment. Currently, we're in Chris Zappa's UAV lab. I work with Chris and his team to design instrument payloads for his drones, the Latitude HQ-90s. I work with Scott to figure out how to take some of the state-of-the-art cameras, infrared sensors, radiation sensors, and package it into a size small enough to fit inside the nose of our drones, the UAVs. On this particular project, we've worked to design a base system that can work with a variety of instruments. And we've iterated on this through multiple projects on the year in order to get it more compact. And anytime we can reduce the weight, we increase the duration of our flights, and longer flights is just more efficient. We get more data with each trip. Plastics often get very brittle at cold temperatures, or they can get soft at extremely high temperatures. So going with the aluminum, it's both lightweight and very strong. We purchased a professional quality 3D printer, which actually prints a plastic that's embedded with carbon fiber. So it's extremely rigid, resistant to cold temperatures, and we can make extremely thin walls on enclosures like this one. So we ended up with a lighter weight part that perfectly fits our electronic system. You can see there's complex folds and ridges and mount points all throughout this piece that would have taken days to try to incorporate into this original glued together carbon fiber box.
Just to show, this is the cover that we put during flight. Fits right down. Hard drives for the imagery go here, and then there are two screws that hold it on during flight. And this just protects from weather, people touching wiring, or whatever it might be as they're handling, and also provides that interference shield for the components electrically.
Before we actually start building anything, first we make a model of it on the computer in order to try to figure out where everything will go. So after we have a 3D model, I can send it to Chris Zappa and Scott, and we first make a 2D drawing, but we can also have a 3D model so that you can really look at each of the corners of the design and make sure that nothing's interfering, that everything fits like it should. With a model like this, we're able to send it to the Latitude, the aircraft manufacturer, and work with them to get an approved layout and position for each of these instruments. So what we're looking at on the Metflux payload is this outer transparent shell is the nose of the aircraft, and mounted within it are each of the instruments and the data acquisition system. So each of these, the various instruments, produces data in a slightly different way. All of it needs to be processed in a unique way in order to collect the data onto a hard drive that can be analyzed after the flight's been completed. Moving forward from there is a gyroscopic inertial measurement unit, an IMU, which accurately measures the motion of the aircraft so that we can take the GPS position and understand the exact locations of each of our instruments. So moving forward from the IMU is the LiDAR, which uses lasers to measure distance in order to record the topography of whatever the aircraft is flying over.
So Ryan's been talking about the Metflux payload and the model, and now we're actually going to go put it all together. It's sort of together right now, but we had to move it off all of its brackets to make some alterations to the main bracket. Now that Ryan's finished his machining in the shop, we're going to put all the components back on. And it really is a two-person job. These payloads are pretty small, but a lot of things are very tightly integrated. There's not enough space to move around. Sometimes you have to hold something while you screw something else. So we'll get to see all those fun things happen.
Ikaw, Viksikukun, New Pack for Ice Bridges.